One. Recording. Last time it said preparing, and it didn't record. All right, here we go. So this is just like the lesson from yesterday. And in fact, anyone watching at home, this lesson will supplement from yesterday. In fact, it could completely replace yesterday. So if you missed yesterday because you were testing, just watch this lesson or pay attention, and it will cover from yesterday. All right, inverses of non-quadratics. One thing I do want to I want to point out here is an inverse reflects across a certain line. Can anybody remember what line it reflects across? Yeah.
Wasn't it y equals x?
Y is equal to x. And what does that look like? It just goes y is equal to x, so x is 1, y is 1. X is 2, y is 2. X is 3, y is 3. So essentially it just makes a 45-degree line like so. Okay. Now, when we have an inverse, we need to consider that it's going to be flipping across. We're going to have to flip across, okay, across this y is equal to x line. And because that's the case, that's why we're choosing the increasing portion of the function, and that part is going to be reflected across, okay? If we had both of them reflected, then we get into some trouble as far as our horizontal line test and our vertical line tests, okay? Does anyone remember what the vertical line test was helping us to figure out? The vertical line test? What was that? Vertical line. So an example of a function that passes the vertical line test is x squared, so a parabola. That crosses the vertical line test. Okay. How about, yes? No?
Wait, wasn't it to make sure that there's not more than one point if you have it on the line? It's not more than one on the x, on each x.
Right, a vertical line test,
yeah.
It has to only touch your function one time. And in fact, that is the definition of a function. Now, there are things other than functions. So a parabola, right? Parabola, vertical line test would only touch it in one point. Okay, so it is a function we can find the inverse from. A circle is, we have an equation for a circle, but that's called a relation because a circle, a vertical line test will hit it twice. Okay, so this is just looking at what is a function, what isn't a function, and with the relation, it's different as far as finding the inverse. So we're dealing with just functions here. I'm just reminding you, vertical line test proves it's a function. Horizontal line test is going to show if we can find no, it's not here yet. Find the inverse. Okay, so let's see. We have to restrict the domain in order to find the inverse because that one-to-one correspondence or horizontal line test tells us if we could find the inverse for this. So without restricting the domain, would this pass the one-to-one correspondence or horizontal line test? No, it wouldn't, because you look here and you see that if I make my line here, say this is, vertical line test, y is equal to 3, we have 2 points that share, say this is -1, 3. This is, 5, 3. We have 2 things that correspond to one of our variables. So in that case, we cannot find the inverse of it. Okay. That's why we're going to go ahead and restrict this. And where do you think I should restrict it? Say if this is at 2, I should restrict it from that point because that's when it's increasing. Okay, so first step is to see where it's increasing, and we're going to find the inverse of this portion. So I would just have to put my domain restriction there at, it's going to be 2, positive infinity. Okay. This is important, and we do this initially when we have these functions in order to find what the domain and ranges are going to be. That's pretty easy because they just switch. Once you know the function's domain and range, the inverse function is going to be the opposite values. I have some Desmos set with graphing so we can see how this actually works out. And I don't mind actually if you use Desmos to graph it first, to see where it's increasing. You can use Desmos in technology. That's part of the standard, exploring the standard. So the same thing, we're going to go ahead and restrict part of the function, restrict the domain and range. For number 2, we're going to switch the x and y, solve for the new y, and relabel it with our inverse notation. And then use the composition to check. So we take our answer to the inverse, we put it in for x in all the places for the regular function. And then we see if we can get x at the end. Okay. So let's look at this one right here. let's see. What does the third root even look like? We probably will be okay. Let's go ahead and pull this over. Let's look at the third root. So here's x is equal to y. And I want you to look at that, and with your partner, go ahead and figure out what is the interval where it's increasing. It's increasing where? This is kind of like a little, in the warm-up this happened. Tell your neighbor. Where is it increasing?
Positive infinity, negative infinity to positive infinity.
All right, let's see. Daniel, what do you think?
We said the whole thing looked like it's increasing.
The whole thing.
Yeah.
So we don't have to restrict the domain here because it's all increasing. So I'm just going to lift this up. We probably can still see nothing. We can see nothing still. All right. So I'm just going to pull this up and down. I think you could still read that even at home. So the domain for the function, the actual function before we find the inverse is negative infinity, positive infinity. How about for the range? If you can kind of see it, it's going down this way. Pull it down real quick. Hold it. How about the range? Talk to your neighbor real quick. I'm hearing some good inputs here. Right. This is more straightforward when it's all.
Domain is the x and then range.
Okay, help me out, Lincoln. What is the range for the function? Right? Because this arrow goes down. It's still slanting down for good. This one is going up for good because we know the arrow's on the sides. If I zoomed out, it would still keep continuing that direction. So we're going to keep turning this on and off so you can all see still. All right, so negative infinity, positive infinity. This is pretty straightforward. And then what is the domain and range for the inverse? Remember, we just switch them. Bada bing. Bada boom. Bada bing. You gotta say it as deep as you can. It's like a commercial. TripAdvisor?
No, wait, I know. I thought it was like something.
It's like
It's financial.
I like the hamburger commercial.
I thought it was Allstate. Like,
I love this side tangent. We're gonna walk back from all these side tentacles. Let's get back to the main road. Yeah. Let's go ahead and do number one. Step number one we've already done. Step number two, we need to first denote that this is y, third root of x plus 2. And then we just switch them and we solve. So I want you to go ahead and solve for y right here. Remember that when we're solving for and isolating the variable, it's like an onion peeling from the outside in. So in order to get to the radicand in here, we have to first deal with this cubic root. So I want you to inverse that to both sides of the equation to start. And actually from there, it's just one other step. Change your notation, you got your inverse. So I hope that this first portion's pretty straightforward. Composition check takes a little work, but I am confident in you all. All right, the composition check is too hard to see down there, so I'm just going to write it here for you all. All right, it sounds like you all got to the final notation. You guys are good? Okay, so first off, y'all, x to the third, y plus 2, minus 2 minus 2, x to the third minus 2 is equal to y. But that's a y and that's a y. Remember what we're doing. We're finding the inverse, so what do I need to do with my final notation? Function notation inverse, so function notation showing the inverse is x to the third minus 2. Okay. So let's go ahead and put in, as you're copying down that, I'm going to put in x to the third minus 2. Great. Great. All right, pulling it down. Good. All right. Is this function reflected across x is equal to y? It is. Let's see. The original function's in red. The inverse function's in green. You see how it works? It's a fish.
Oh, sorry. If you like take never mind.
See, if you take this part and you wrap it around that
No,
side.
it's literally just if you take it off where it hits y equals x.
Mhm.
See the point where those two take off the things past that, and it looks like a fish.
Oh, I see it. It's like
kind
a
of, yeah, it's more like squid. There you go.
squid.
Yeah, that's right.
That was the correct answer. There's no correct answer. It's like looking at clouds. Sorry, that cloud is not a fish.
Wow. Okay.
It doesn't make sense. You can,
Sounds like you're rooting for his imagination.
I am the imagination ruiner. That's actually my nickname. How'd you know, Luke?
That was my name.
Back in
That's not true. I value imagination so much. All right, here we go. We have the inverse here. I need you to go ahead and work as hard as you can here to plug this in. So we're plugging in the inverse value. We're plugging it in for f of x. So in essence, we have a new pen, and we have f of x. Well, let's go to f of x plus 2, and that's going to be equal to the cube root of x to the third plus 2. Sorry. I'm going to start over by flipping the paper. This new thing is messing up. All right, watch. We're going to take the first function, and we're going to put the inverse within the first function. X to the third minus 2. Watch what's going to happen here. We plug it in where there is an x on the other side. X to the third minus 2 plus 2, and go ahead from there, work out the rest. You know you did it right if you get it x as your final value. This gets really cumbersome, actually, if you're dealing with certain quadratics or and you're a little cumbersome over here. And actually, we're not finding the composition check for absolute values. So just hold on that. If you're super curious, you're like, what happened? It's not here. What's negative 2 plus 2? 0. So we're finding the inverse. Really, we're doing the function of the inverse. We have the cube root of x to the third, which is x. So did we solve this correctly? We did. And that's the full problem. Use Desmos to find your domain and range based on the increasing. From there, set up what the domain and range is going to be for the inverse. Complete the inverse and then double check. So that's the full process there. Can we do this, you think?
I think we I don't want to speak for you. Actually, no, I take it back.
You think back.
I will work.
Just to be safe.
We don't think we work.
Gotcha. Okay, let's look at the next two values here, and I want you with your partner, go ahead and tell me what's going to happen with this. So now I'm looking at g of x is equal to 1 over x. All right, here we go. Talk with your neighbor. Where is this increasing? Where is it decreasing?
Whoa. What's that? Wait. It's all.
This one.
No. They're all deep. It's always deep. It's always.
No idea.
Yeah,
1 second. I'll get this,
it's
get this over here without knocking this off. All right, let's see. Cold calling. Nadia, help me out. Where is it increasing? Can you give me an interval? Or is this another trick question? What do you guys see?
It's always decreasing.
Downhill. Shoo. Downhill as well. It's all decreasing, right? It's all decreasing. So when it's all decreasing, we have no choice but to use everything that's decreasing. So I want you to go to put the domain and range. Sorry, after I asked you, I realized it was kind of a trick question. I want you to go to put the domain and range for everything again. Everything. These are all increasing, or they're not increasing anywhere, so they're all decreasing. So let's go ahead and put that in for, let's put that in for our domain and range here. Negative infinity. Hang on, I was hoping actually this one would have. 1 second. 1 second. Yeah. What number can we not have involved here? You guys like all my sound effects today, though. So we keep them coming.
Always on fleek. Silent sound effects on.
What x value, which is going to change our domain, what x value is not included in the graph? 0. What y value is not included in the graph?
0.
All right. Some of you last year didn't learn some notation here. Set notation. When you have a U, U stands for union. It includes both options. So if I was doing playing cards and I had the union of sevens, let's say clubs and diamonds, it would be all the clubs and all the diamonds. Upside down U is intersection, and that would be saying the intersection of clubs and a 7. The intersections of clubs and a 7 is a 7 of clubs. Okay, that's like a very quick Unit 4 from last year breakdown. So watch how I'm going to write this. I'm going to say, yeah, the domain goes from negative infinity. Get in there. Negative infinity to 0. Union, a U, union, set notation, 0 to positive infinity. So I want you to go ahead and do that as well for the range and then switch them. Actually, they're going to all be pretty similar here, right? Okay. But this is a pretty straightforward function. If we had a transformation, moving it up and down, a shift, then we'd have a different value. It wouldn't go to 0. We'd have a different asymptote situation. All right? So, let's see. What should it be? Give me something. Give me a store.
Target.
Target, men's section can help you.
Oh my god.
Okay, perfect. All right. Ellen, where'd Ellen go? Ellen, we got an early dismissal. Okay. That's the best way. I'm going to just call up for a store. All right. They like it. They laugh usually. She didn't laugh, but I'll get her next time. She was confused for a second. All right, here we go. Here we go. Just having fun. What is going to happen? What is going to happen to the domain and range of the inverse? It's going to be the opposite, right? For convenience, well, no, I better do it. Minus infinity, 0. Go ahead and jot it down for this example problem. And we end up with the same thing over here, negative infinity to 0, because we don't count 0. Okay. Once you get the domain and range from the graph, then go ahead and start our process of finding the inverse. And find the inverse of that. So I just changed it from function notation. And now let's go ahead and do the inverse by doing something. That's your answer to your deductive proof. Something. And while you're doing that, over here, can you see? I'm going to put the inverse up, which is here. Oh yeah, it's the same thing. Who can look at the graph and know what the inverse is? You can do it?
Yes. Me too.
The answer is something. All right, Gene, give me your input. Did you get it for sure?
What it would look like?
Yeah.
Yeah.
Then, okay, good. Then what will it look like? It would be the same thing. Think about this. X is equal to y. Y is equal to x here. If we flip it about the y is equal to x, what do we get? Same thing. I don't mind if you can look at the function. If you're 100% sure it's something really obvious like this, and you could see that it flips to be the same, it's in your benefit to notice it that way. You're noticing it with algebra, but this is really a quick problem. So, we switch the place of x and y, 1 over y. Anytime you're in this situation, they actually do just switch places. But if you wanted to, you could see that you multiply by y, and you divide it by x, and we get y is equal to 1 over x. Change that function notation. And that's it for that. Now go ahead and let's do the composition check. So let's check the composition here. I made one mistake here because this is g of x. We started with g of x. We should probably keep it. That's what I changed right there. Now it's g of x. Okay. Now, I'm going to let you go ahead and try this next step here on your own. Essentially, we're taking g of x, and we're putting in our inverse, that entire expression, anywhere we find an x in our original function. If you don't know where to start, ask your neighbor right now so you don't fall behind. Ask your neighbor real quick. Not sure where to start? Because we know what the inverse is. Here's my inverse. So I take this. You see it? Hey, cookies?
Yeah.
I didn't even eat any. Yeah. I didn't do what I was supposed to. Good job. See ya. All right. Let's see. Justin, help me out. What are we going to end up with?
You should end up with 1 over 1 over x. Or 1 divided by 1 over x.
Got it. We got a complex fraction here. I mean, it's just going to, you can see how since you divide by a fraction, it's going to do the flip. So we're going to end up with, essentially, this is, 1 over 1 times x over 1. X, did we do this correctly? We knew from seeing the graph we did this correctly, right? I mean, some of us saw it. But if we're flipping, we can see pretty quick that it's the inverse is the same as the function. So good shape. Okay. The only bit here that's a little tricky for example 3 is it's getting into absolute value. But luckily for absolute value at this point, we're not going to check the composition. We're going to just verify with the graph. So let me go ahead and put on, I don't need that then. Let's put this one up. All right. So talk with your neighbor. This is our original function here. We have, let me just check if you can see it. Whoa. All right. Talk with your neighbor. What is the domain restriction for our function here? What is our domain restriction? Talk to your neighbor.
But you restrict it.
Oh, yeah.
Okay. All right. Adriana, what'd your group think?
We said negative.
The domain? The domain.
And then 0.
Hold up. So give me the full bracket for the domain for the x. It's going to be between. Maybe you said I didn't hear you. You're right. Just finish it up.
-2.
-2 is where it starts.
Mm-hmm.
It's increasing there. Where does it end?
0.
It only increases to here. But then I look past 0 and it's still going up. So what would we call it? To infinity. Yeah. And anytime you can see this function is going to keep going. There's no reason for it to make any change. And in fact, that's not how it would. It would have to be like a piecewise where we say from here to here is this function. And we're not dealing with that, luckily. Ooh, that would be fun, though. All right, so someone else, let's see. What would the range be? Let's go with Ella. What do you think the range would be?
I said 0 to positive infinity.
0 to positive infinity, right? From right here up. Very good. All right, so let's go ahead and fill in and start to fix this up over here. Hey, don't do that. Let me see if people could see. Nope. Oh, yeah, they can mostly see. Let's see, Daniel, can you pull the curtain forward? I'm seeing a glare. And pull the other one back if you can reach it. Yeah. All right, I think that'll work. Okay, so we found that the domain was -2 to infinity. The range was 0 to infinity positive. So go ahead and switch those up. We always remember that the inverse function of the function, the inverse is switching the range and domain. So let's go ahead and do that. And the reason it does that is because we're going across the line y is equal to x. So think about that for a second. Why does that help in proving why they switch? In fact, that's Reese's worthy. It's kind of... Actually, I don't know if you guys can get that idea. Maybe you could think of it spatially. Like think of it as far as the spatial position. It always sounds like I'm saying special in this weird accent. Spatial. Now that's all I hear. It's fun. Think about it spatially. And if we flip this across the y is equal to x, what happens with the point? Here's an easier example. What happens, Luke?
Wait, what is it? Stay in the same place. Wait, I seem to have misinterpreted the question.
That's fine. Jackson.
Just go to the next, or the other -2, and then like the line is still going the same way.
This guy, if we made a triangle here, we could find what this distance is, right? If I go across the y-axis, equidistance out, it's going to start here instead. But that would start, instead of starting at the x value being -2, now the y value would be -2. You see how that's going to flip? So spatially, I can only say spatial. It makes me laugh. All right, so we're going to test that out when we get the inverse. I'm going to put it on here as well. I want you to go ahead and just do our process here. Actually, I'm going to work with you on this because this one has something that's kind of interesting that happens. Because we have an absolute value, we just have to remember one thing here. Well, first we're going to switch. X is equal to y plus 2. Okay. Side note, if I had this, whoops. If I had this, no. My hands work, I promise. What values for x would work in there? 8 and -8. So what you're saying is the version of x would be 8 and then the negative version of that. Okay? So that's why over here, this is where we need to branch it. We need to branch it because watch. We know this one. This one works, the positive version of it. That's the positive branch. The negative branch of this is going to be the entire expression of y plus 2, but what? The negative version. So distribute that negative, solve those all the way down, and we're going to see that we end up with 2 options, and then we'll assess it. 2 options, 2 we'll assess. The absolute values are really the ones that we need to do the assessment for. Because anytime we have that branch, we're going to end up with that option. Where we're going to have to choose and visualize using graphing and confirm it that way on which one is, in essence, our inverse. But here we end up, let's put the y over there, put the x over there, so we get y is equal to negative x minus 2. Okay. Right? Is that okay? Jackson?
Oh wait. Never mind.
Because I just added y minus x. I did it all in one step. You could have also added 2 and then multiplied by negative 1, I guess. All will work. But I want you to visualize what we know from just, we have 2 inverses here, but there's only one that we're going to use. So these are the inverses. And if you can visualize, graphing these, you could probably see which one we'd use. And in fact, I'll put both of them up on Edmodo, or on Desmos, and we'll see very quickly which one it was minus 2. Okay. Y equals negative x minus 2. Yeah. So, and we would put our domain restrictions here. So, for this one, I would have, what was our domain restriction for it's 0 to infinity. So 0, infinity. You can't do infinity, so I'll put 99. And what's wrong with it? So expression must, that's why. Wrong brackets. Nope. Semicolon. I forgot the syntax for this. And I'm not going to worry about it. We'll just assess it based on where the domain is. How did I? Right, I did brackets. Those brackets. Oh. Oosh. I don't understand the way that comma is used here. I'm not worried about it because we know where the domain is. And just in looking at this, which one is going to be our inverse? Yeah. Y is equal to x minus 2. Y is equal to x is the blue line. Minus 2. Y is equal to x minus 2. So we end up going down. Okay? Because the y-intercept is at negative 2. The other one, the other option of negative x minus 2 has a negative slope. This red line is definitely not reflecting our positive increasing portion of this absolute value across x is equal to y. That's not happening. Okay, there's too many things up there potentially. Let me get rid of one thing. Not that one. That one. So you see that this line, I wasn't able to restrict the domain, but we had the domain restriction here based on our initial assessment. So from here up, you can see how that's a perfect reflection across. In fact, we kind of called that. We said that I was going to start here. Jackson?
Isn't the other equation just, it's like this line, but it's just like
right.
going that way?
Right. And if we think about that, and we were to place the domain restriction on it, it is flipping, this line across if we started here and went down. Yeah. But we're only interested in the increasing part of it. Yeah. That's why we're going to go ahead and say, nope, you lose. You win. And that's it. Yes. I want you to go ahead and do this last bit. Go ahead and do the f of, or it's h of the inverse. And I just realized I put it as f. These are h's. How could I do that? All right. Go ahead and knock that out. That's our last bit before I give you a whole 6 minutes.
Okay.
Yeah. Okay, we only need 5. Perfect. Tell you a story then for a minute. Oh, this was the one I said we didn't have to do the composition. Yes. Yeah, right? Okay. So actually we are done with that. Thumbs up, sideways, down. We can do this, right? A little better than yesterday. We got it together. Okay, so keep working on the material from yesterday with the information from this lesson. We won't be collecting this homework till next week because this week we have no assessment. Okay, so that is that. Yeah, to everyone at home, happy Tuesday.